Dear students, today we are going to study the apparent weight in a lift. What do you mean by apparent weight in a lift? Now we consider the situation while we are riding on a merry-go-round or in a lift. We have a nice feeling during the upward journey, but when downward motion starts, we feel giddy. This sensation is based on our weight, the variation in our weight. How the variation in our weight takes place, how we can realize it. Dear students, assume the situation when we are pressing the ground with our weight, that is mg, then earth provides reaction force to balance that weight. You know it very well. And when we jump from a building or from a tree, what happens? Then we are not having any reaction from force from the earth side because we are not giving the action force by our body. This situation is the weightlessness situation. And when we are moving in a merry-go-round, then in the upward journey we feel better as compared to the downward journey. This variation of weight is related to the apparent weight of the body. Now you have two terms to study in this topic, that is the apparent weight and the situation of weightlessness. Now what is the weightlessness or apparent weight? See here in this picture that a person is standing on a weighing machine. The weight of the body is measured by the weighing machine or a spring balance. When a body of mass m rests on the surface of the weighing machine, what happens? Its weight acts vertically downward direction. On the other hand, the surface of the weighing machine exert the normal reaction force that are equal and opposite. The weighing machine read the normal reaction, and this normal reaction read by the machine is known as the apparent weight of the body. This weighing machine shows that this R is equal to mg. It means the apparent weight of the object is equal to the actual weight of the body. Both are equal. Now students, you have many kind of situation. What are the situation? Number one, when the person is sitting or standing in the lift and lift is moving in upward direction, first situation. Second situation, when the lift is moving in downward direction, or the third situation that the lift is not moving at all. In all these three cases, how you will study the apparent weight of the body. This is showing you the three cases. First one is this is the lift and the person is standing on the floor on a weighing machine. Now you will observe what changes will take place in the weight of that person. First situation, when the lift is moving in upward direction with a given acceleration a. How many forces are acting on the lift? Take it as a free body diagram first. How many forces are acting? The weight in downward direction, the normal reaction force in upward direction, and the net force, that is m into a, the motion of the lift in the upward direction. It means this reaction force is more than the weight of the body. It means the net force acting in upward direction. So what will be the equation according to you? This R is greater than mg. So this R minus mg will give you the net force, and that net force is m into a. And in second case, second situation, what is this? Again, consider the free body diagram, the weight in downward direction, the normal reaction in upward direction, and the net acceleration in downward direction. Now what you can say, that the lift is moving net in downward direction means the net force is acting in the downward direction. It means the mg is greater than r. Mg is greater than r, then mg minus r is equal to the net force. What is net force? That is ma acting on the lift. And in third situation, what is there? Two cases are possible. Either the lift is at rest, no velocity, hence no acceleration. Second situation, when the lift is moving with a constant velocity. If velocity is constant, then acceleration is 0. In this situation, the lift may move in upward direction or may move in downward direction. So what will be the equations in these three possible cases? That is, the first case, lift is moving in upward direction. You have calculated the value of r from this equation. That is, r was greater than mg, so r minus mg is equal to ma. The apparent weight of the body becomes more than the actual weight. Actual weight was mg, so this becomes mg plus ma. So apparent weight becomes more than the actual weight. The next situation, when the lift moves in downward direction, it means this mg was greater than r. The equation becomes mg minus r is equal to ma. It means the apparent weight is less than the actual weight. How much less? Mg minus ma, this much amount, it will reduce by this much amount. The apparent weight will be less than the actual weight. The third situation, when the lift is at rest, it means the acceleration of the object is 0 or the velocity is 0. Why acceleration is 0? At rest, no velocity, no acceleration, or in uniform acceleration case, the velocity is constant. In that situation, a is 0, then r is equal to mg. It means the apparent weight is equal to the actual weight of the body. And the next situation, I have told you about the free fall, that when the object is moving freely, then the acceleration reaches to the value acceleration due to gravity. And in this situation, r is equal to m into g minus a, 0. The apparent weight is 0. This is the situation of weightlessness. Now one question also arises here. What happens if the acceleration becomes greater than the acceleration due to gravity? What will happen? The r will be negative, and this is the rarest situation. In this situation, the object will stick to the ceiling. It will start moving in upward direction, and this situation is rare to achieve. In this way, you can discuss the different kind of situation moving in upward, downward direction, or in the stable case. What is the conclusion from here? That is, when object is at rest or moving with constant acceleration, then true weight and actual weight, apparent weight are equal. When the body is moving with lift in upward direction, then apparent weight increases as compared to the actual weight. When it moves in the downward direction, then apparent weight decreases, and in case of free fall, the weightlessness situation is there. Now you can practice this numerical on the basis of these formulas. What is given to you? A body of mass 30 kg is resting on a weighing machine. Then calculate the apparent weight when the lift is moving in upward direction, in downward direction, and in case of the free fall. Now you can calculate these values. I will give you more numerical for practice, and now do the quiz after this.